Hello everyone, my name is Vivek Kaur and welcome back to my YouTube channel Better Call Paul. We are in the YouTube playlist for machine learning algorithms. Here in this playlist, we are going to learn each and every machine learning algorithm, why it is used, what is the benefit of using this algorithm, what we get actually, what is the statistics used in this algorithm, what is the math behind this algorithm, how to get the output, how to correct the model's accuracy, and so on. In the previous two videos, we have seen how decision tree works. Then we see how random forest works, why we use random forest. And in this random forest, we see some words like bagging, boosting, and so on. So bootstrapping. So we will now see what is the actual concept behind these words. What is bagging? What is bootstrapping? What is boosting? And then we will learn what is gradient boosting. After that, there are ongoing videos like what is extreme gradient boosting, means XGBoost, what is cataboost, light boost, and so on. So, what is exactly boosting, bagging, and bootstrapping? I will explain you now. So, what is bootstrapping? First of all, we will see what is bootstrapping actually. So, let's say we have a huge data set of hundreds of rows, or for understanding, we will take an example like there are 100 resume on the table of interviewer. Interviewer has to pick a resume. He just pick a resume, then close his eyes, put that resume again on the table, and then again, by closing his eyes, he pick one resume again from the table. So this putting, picking, and putting on the table, picking up, this process continues. So this is called as bootstrapping. Why it is different than another random sampling techniques? Because in bootstrapping, you are again putting your file, you are again putting your data into that main data set. So here there are two possibilities. There might be a possibility, high possibility, that you will get the same file again. Means, for example, Vivek Kaur's resume is present in the hundreds of candidates' resume on the table. Interviewer is picking that resume file and see looking at it again, putting back on the table, and then again taking one resume again. So there is a high possibility that Vivek Kaur's resume will again got picked up. Again means two times, three times, 10 times, many times. Or there is also higher possibility that, for example, someone else resume, Ramesh resume is present onto that table. So Ramesh resume is also present on the table. Interviewer is picking 100 times. The files are picking 100 times. So there might be another possibility that Ramesh resume is never picked up. There are some files which are never touched again. There are so many files which are picked up again and again, again and again. So this technique is called as bootstrapped random sampling. So this is the concept behind bootstrap random sampling. After that, there's a concept that bagging. What is bagging? Bagging means you have many models, and each model is having their own opinion, their own output. So you are collecting the output of all the models, whatever maybe you are doing their mean, you are doing their median, you are doing their mode, and combining their outputs, you are showing one particular output. So the example behind this bagging is, for example, there are 10 interviewers and one interviewee candidate. So, 10 interviewers have their own opinion whether to hire that candidate, yes or no. 7 interviewers are saying yes, 3 interviewers are saying no. So, the mode is saying that the interviewer should get hired. Yes, yes is means the final output is yes. So this is the bagging means you are you are taking the opinion of all the interviewers, all the models, and then finally giving finally generating one output, whether it is yes or no. So that is bagging. Bagging is used in random forest. that this thing is used in random forest. Now another thing is boosting. Boosting is not used in random forest. Boosting means what? See, in random forest, you are parallelly processing all your models, and they are taking their models and taking their outputs and showing the result. But in boosting, your models are present in sequential manner. For example, there is a model which gives one output, then another model uh, calculate the differences between the generated output and the actual output, actual price, whatever it is, actual original value. It is taking the difference, correcting the mistakes, whatever the mistakes he has made, why the difference is too high and too low, correcting the results, correcting the mistakes, and again generating the output. So the second model is more accurate than the previous model. Again, third model is in sequential manner ahead of second model. He is comparing the price of the output of the second model and compare it with the original value. There might be some errors, mistakes. The third model is correcting the mistakes and errors of the second model and generating the output. Likewise, there are many models. So, for example, first model will give you 100 error. I'm just giving value. Second model reducing the error and giving you the output which is showing 50 error, 50 value error. Third model 30, fourth model maybe 10, fifth model maybe 5, sixth model maybe 2, and so on. And by this way, you are getting the most accurate answer by doing boosting. So this is boosting. Now we have learned what is bootstrapping, then what is bagging, and now boosting. There are various boosting techniques. One is gradient boosting, another is extreme gradient boosting, another is light gradient boosting, light GBM, another is kata boosting, kata gradient boosting, and so on. Now I will show you on my notepad and means on my this pen and pad how exactly the math run behind gradient boosting. So let's move to one more screen. So let's take an example of this. Okay, now you can see my screen. Let's take an example of house price prediction. So these are the house number one, two, three, four. This is the size in square feet, 500 square feet, 700, 1200, 1200. And these are the bedrooms, one, two, three, four, and these are the actual prices. Now we are going to make a model. So our first model, let's assume our first model is taking the average of all these houses. So what is the average of this? 2 into 7. Um, oh, means okay. 45 will be the price. Our model will predict that the price of that house is 45. But it is not the same case because if we see error, then you will see our model is saying that the price of any house is 45, plus minus 45. It is saying plus minus 5, 10 something, approximately 45. But here you can see minus 20 is the error. Here you can see minus 10 is the error. Here you can see plus 10 is the error. Here you can see plus 20 is the error. So our first tree means here I will write down first tree or first model. You can see model is telling 45 is the price. Second model is what we are going to calculate. So here the sum, let's say sum of this error is 60 divided by 4 is equals to 15. So the second model's logic is it will check with another feature, that is size feature, size feature, and if the size is less than 800 square feet, then the error is, you can say, minus 15, means it will take this value 15. So it will be minus 15. I will write down minus 15 because the size of 800, it is predicting if the size is less than 800 square feet, then minus 15 is the error. If the size is plus more than 800 square feet, then it will calculate the error as plus 15. Okay. So the new square feet, the new prices will be what? 45 minus 15, 45 minus 15, 45 plus 15 plus 15. So second model's price prediction will be here 45 minus 15 is 30. 45 minus 15 is 30. 45 plus 15, it is 60, and 45 plus 15 is 60. So this will be the output of the second model. But here also there are some differences, some errors. So here are another errors. You can see another errors are what? It is plus means actual price minus predicted price. 25 minus 30 is, yes, it is right. Plus 5 it is giving. Here it is giving minus 5. Here again it is giving plus 5. Here it is giving minus 5. Okay. So these are new errors. But the new errors are smaller than the previous errors. Means first model's error. The errors are lower in second model's error. Okay. Just one mistake. These are minus 5, these are plus 5 because we calculate on the basis of actual price minus uh, predicted price. So actual price is 25 minus predicted price is 30, so it will be minus 5. So this should be minus 5. I will correct it. So draw. So here is the right minus 5 plus 5 minus 5 plus 5. Now the second tree will, now the third model will assume like this is our third model. It will assume like if the square feet area means there are tens of features are there, but for example, we are taking only two features. One is size and one is bedroom. So if the size is less than 800 square feet, then there will be minus error. Means if the size is so sorry, if the size is less than 800, then the error will be minus 5. If the size is greater than 800 square feet, then the size will be plus 5. So third model will be uh, minus 5, and it will be plus 5 errors. So our new prediction will be means these are going to compare with this, means these are going to calculate with this. Third model's output will be 25, means 30 minus 5. 30 minus 5 will be 25. Here it is 65, and again it is 65. So these things means these are going to compare with our actual prices. Okay. So here the error is 0, here the error is plus 10, here the error is plus 10, and here the error is 0. So you can see we have eliminated a lot of errors. We have very small errors. Previously we have 60 error count, means like every for every houses we have some errors. Then we reduces the error, and in the third model we have even reduces the errors. Now, this is how we have eliminated the errors. Step by step, there are many models there which will take some another feature. For example, we have taken this size feature and bedroom feature. There might be some features like criminal rates or nearby bus stand, railway station, or nearby means the distance between banks and houses or schools. a lot of things will be there. Um, Urbanization and so on means whatever the data present in the real estate data set, we will check on those features and improve our next models and reduce the error, increase the accuracy. This is how gradient boosting works. Now, if we put this model onto a test data, and for example, the test data is having, for example, H5 is the house number, and size is 900 square feet, bedroom, whatever bedroom it is, and it is asking what should be the price. So this 900 goes to first model. First model is saying 45 LPA. Oh, sorry. First model is saying 45 lakhs. Then because this is 45, this is the output of just average. Then second model is checking whether the size is greater than 800. If it is greater than 800, then there should be plus 15. Okay, so plus 15, it will be 60 lakh. Then again, third model is saying if the square feet area is more than 800, then add plus 5. So 60 lakh plus 5 will be equals to 65 lakhs. So this is how means if the square feet area of that house is 900, then the price of that house will be 65 lakh rupees. And this is a result of a gradient boosting model, which is far more better than your random forest model or your decision trees model, because it is correcting the errors of your previous models and giving you the output. So this is how gradient boosting works. So we have seen how gradient boosting works. Means I tried my best to generate a simple data set and how I can explain you better. But in industry grade projects, in big scale projects, you have a data set having a lot of columns, a lot of features are there. So there is a high chances, there is a huge scope of selecting various features. Means we see two times we use a square feet area, one time we use a number of bedrooms. But in industry grade projects, big projects, you have hundreds of features. You can try on new features, new columns, and you get the better accuracy. Accuracy is measured on the test data set, on the unknown data set. If the accuracy is higher, then you can see that your model is working very best. Your model is predicting the best. Your If your prediction is good, then your business decisions are good. If your business decisions are good, then you will make more revenue. You will avoid your losses. It will help the business analyst, the finance analyst to take the decisions, to take the calls, what to do next or what not to do, to explain their customers, to explain their clients that we have used these models and these tools and all. And we come up to that point that yes, this is right, this is wrong, this is the price, this is not to select, this is to select, and so on. So this is how gradient boosting works. Just remember one thing: gradient boosting means you are just improving the mistakes of your previous model. So that's it for today's lecture. In the next lecture, I will explain you how extreme gradient boosting works. After that, there are many more videos, many more machine learning algorithms we are going to cover. Till then, take care. Today is 14th of February, Valentine's Day, and it is now 3 p.m. I will launch this video after some time. So thank you for very much for watching this tutorial. Please do like, share, and subscribe. Thank you very much. Bye bye.